Hi there, this lesson, A-level physics, work, energy, GPE and KE. GPE is gravitational potential energy, KE is kinetic energy. So let's have a look. The objectives: recall the equations and apply them for work done, GPE and kinetic energy. And then we're going to apply the conservation of energy laws to calculate the speed of falling masses. So what is work done? Work done is force multiplied by the distance moved in the direction of the force. This equation is used at GCSE. So work done is force times distance. You could also get distance as an S, which just means displacement. Work is measured in joules. It's a scalar quantity. Remember, anytime if you wish to make any notes, just pause the video and then continue. If the direction of the force and the distance moved are not in the same direction, however, like this, we have to use work is equal to force times distance multiplied by cos of the angle that separates them. So question 1. When we do questions, just pause the video and then play for the solutions. So work done is force times distance, so FD. 10 kilonewtons is 10,000 newtons multiplied by 40 centimeters, which is 0.4, and 0.4 times 10,000 is 4,000 joules, or 4 kilojoules. Question 2. Calculate the work done by a child of weight 400 newtons who climbs up a set of stairs consisting of 14 steps each of height 25 centimeters. So work done is force times distance, and the force is the weight of the child, which is 400 newtons, multiplied by the distance, which is 25 centimeters or 0.25 meters, multiplied by the amount of steps, 14 steps. Put that in our calculator and we get 1,400 joules of energy. Let's move on. Question 3. Calculate the work done by the wind on the yacht in the situation shown below. So this is work done is force times distance multiplied by cos of the angle between them, because they're not acting in the same direction. So the force is 600 newtons multiplied by a distance of 40 meters multiplied by cos of the angle between them, which is 25 degrees. So that gives us 21,751 joules, or 2.2 times 10 to the 4 joules of energy. Now let's move on. So in this example, a 35 Newton force acts through a distance of 6 meters. The work done is 150 joules. Calculate the angle that separates the force and the distance. So it's work done is force times distance multiplied by cos of the angle. So the work done is 150 joules equals 35 times 6 for the force on the distance, which is 210, multiplied by cos of the angle, cos theta. So if we do inverse cos of 150 divided by 210, if we put that in our calculator, it gives us an angle of 44 degrees. Bit more information then, force distance graph. So if you get a graph and it's force against distance, the area under is equal to the work done. So in this one, you just do force times distance. If the graph's like this, it will be the area of the triangle underneath. And more likely you'll get a graph that looks like this with a curve. So what you have to do is count the squares on the graph individually. So a quick question. Calculate the work done by the brakes of a car if the force exerted by the brakes varies over the car's braking distance of 100 meters as shown in the graph below. What we need to establish then is that when a car is moving, it has kinetic energy. And to stop the car, we need to get rid of that kinetic energy, convert it into other forms. So there is work done by the brakes. So we convert the kinetic energy of the car into thermal energy within the brakes, which is then dissipated into the surroundings. So first of all, we need to know the car's, well, the area under the graph for this particular car. So we've got area A. So this is 1,000 newtons, because the axis is in kilonewtons. So it's 1,000 newtons multiplied by a distance of 50 meters. And then because it's a triangle, we need to divide that by 2. So that gives us 25 kilojoules for area A. And then area B is 1,000 newtons, 1 kilonewton, multiplied by 100 meters. So we've got 1,000 for area B. 1,000 newtons multiplied by 100 meters, which gives us 100 kilojoules. So the total work done is just 100 plus 25, which gives us 125 kilojoules of work. Hopefully you got that right. Let's move on. So energy, GCSE stuff really. Energy is needed to move objects, to change their shape or to warm them up. Work is a measurement of the energy required to do a particular task. So we can safely say that work done is equal to energy change or energy transfer. And energy, of course, is measured in joules. The conservation of energy, another important principle. The principle of the conservation of energy states that energy cannot be created or destroyed, only converted from one form to another. So energy doesn't just disappear. It's always constantly converting from one form to another. Eventually, scientists hypothesize that everything will just become thermal energy. So let's move on. And furthermore, please just remember that all forms of energy are, in fact, scalar quantities. So kinetic energy, again from GCSE. Kinetic energy is the energy of an object because of its motion and its mass. So kinetic energy is half m times v squared. Please remember, however, just go back a second, that this is indeed speed, it's not velocity, because velocity is a vector. So if we multiply by a vector quantity, that would mean that the energy is a vector, which just isn't true. So the v, even though it's a v, actually means speed because it's a scalar quantity. Let's go forward, do the example question. So it's calculate the kinetic energy of a car of mass 1,200 kilograms moving at 6 meters per second. I'll show you this now. So kinetic energy is a half mv squared. So it's 0.5 times the mass of 1,200 multiplied by 6 squared, which is 36. So that gives us 21,600 joules, or 2.2 times 10 to the 4 joules of energy. So next one, calculate the speed of a car of mass 1,200 kilograms if its kinetic energy is 48 kilojoules. So I'll show you how to do this now. So kinetic energy is a half mv squared. So the speed would be 2 times the kinetic energy divided by the mass, and then we need to square root to get v. So 2 times the energy is 80 kilojoules, which is 80,000 joules, divided by the mass of 1,200 kilos, and then we square root, and that'll give us the velocity, the speed, which is 8.2 meters per second. Hopefully that went okay. Let's see what's next. So question 3, if you want to pause, have a go. Calculate the braking distance of a car of mass 1,500 kilograms travelling at an initial speed of 30 meters per second if its brakes exert a constant force of 4 kilonewtons. So we need to know how much energy the car's got. So let's do the kinetic energy, which is a half mv squared. So that's 0.5 times the mass, which is 1,500, multiplied by 30 squared. If you put that into your calculator, we get a kinetic energy of 675 kilojoules. So that is the energy that's going to be dissipated into the brakes. So for the brakes, we have work done is force times distance, and the work done is the 675,000 joules of energy. Work done in the brakes equals force, which is 4 kilonewtons, times D. So if I do the 675,000 divided by the force of 4,000 newtons, that will give us the distance, which is 169 meters. So hopefully this person is braking very lightly, maybe on a motorway, because if they're braking with full force, they are broken and very dangerous. Right, let's move on to the next. Gravitational potential energy, again from GCSE. So gravitational potential energy is the energy of an object has because of its position in a gravitational field. So basically, if you lift something up, it will gain gravitational potential energy. So the change in GPE is equal to mass times gravitational field strength times height, or mgh. If you want to write that down. The units, if you're not sure, so energy is in joules, mass is in kilograms, G is, well, on Earth, 9.81 newtons per kilogram. Should know this at this point in time. And height is obviously in meters. So let's have a look. A quick question then. If you want to have a go. Calculate the change in GPE when a mass of 300 grams is lifted upwards by 20 centimeters. G is 9.8. Actually, let's use 9.81. So GPE is equal to mgh. So the mass is 300 grams, which is 0.3 kilos, multiplied by G, which is 9.81, multiplied by the height, the change in height of 0.2 meters. If we put that in our calculator, we get 0.59 joules of energy. So question 2, a change in GPE of 9.6 joules of energy occurs when a mass of 200 grams is lifted at a height of 30 meters. Calculate the gravitational field strength. If you want to have a go at this, please do. So GPE is equal to mgh. So gravitational field strength would be the GPE divided by mh to leave us with G. Then we just put our numbers in. So 9.6 joules divided by mass times height. So 200 grams, which is 0.2 kilos, multiplied by 30 meters. So that will give us 1.6 newtons per kilogram, which is obviously not the Earth, but it is a different place in our solar system. So let's move on. So there's a table that you can complete. I won't go through the answers, but I will just pop them on. It's just a little bit more practice. So the first answer, you just have to rearrange to get mass, plug the numbers in. Should give you 40 kilograms. The second one, rearrange to find gravitational field strength. We've actually just done this one, but it's bonus practice. 1.6 newtons per kilogram. The third one, rearrange to find the height. So it'll be 300,000 divided by 700, which gives you a height of 429 meters. And the last one, 2 kilograms, 2 meters, 24 newtons per kilo, gives you 96 joules. That's also another place in the solar system if you can figure out what it is. Let's move on then. Falling objects. It's very important to know at this stage that if there is no significant air resistance, then the initial GPE of an object will be transferred into kinetic energy. In real life, we know that obviously there's air resistance, so some of the gravitational potential energy will be converted into heat and maybe sound. But when we're doing modelling, most of the time we can assume, if the distances aren't very large, we can assume that the GPE is all converted into kinetic energy. Let's have a look at this one then. If you want to have a go, I'll show you how to do it. A child of mass 45 kilograms climbs up a wall of height 3.2 meters and then steps off. Assuming no significant air resistance, calculate the GPE of the child. So this is straightforward. So GPE is mgh. So that will be the 45 kilos multiplied by G, which is 9.8. If you use 9.81, don't worry. It's just because it says 9.8 in the question. 9.8 multiplied by the height, which is 3.2 meters. Put that in your calculator, you should get 1,411 joules of energy. Then to get the speed of the child, we've just discussed that the gravitational energy will convert into the kinetic energy. So if we have the kinetic energy equation for part B, half mv squared, use the 1,411 joules as our kinetic energy, and then just rearrange to find V. So V will be 2 times the kinetic energy, divided by the mass square rooted. So it will be 2 times the energy. So 2 times 1,411, divided by the mass, 45 kilograms, and then square root. And that will give us 7.9 meters per second. That should be pretty straightforward for A-level students. So let's have a look at the next one. So I want you to have a go at this, pause, and then press play when you're ready to go through the answer. A child of unknown mass climbs up a wall of height 4 meters and then steps off. Assume no significant air resistance, calculate the maximum speed of the child, and G is 9.81 newtons per kilogram. So this time there's no mass, so we somehow need to eliminate it, which is pretty straightforward. So the loss of gravitational energy is equal to the gain in kinetic energy. So we can say the loss of gravitational energy, mgh, is equal to the gain in kinetic energy, half mv squared. So the masses cancel. And we just need to rearrange to find V. So V would be 2 times G times height, and then square root. And if we put that in our calculator, we get 2 times 9.81 times the height of 4 meters, square root. And that gives us 8.9 meters per second. You can do questions like this using the equations of motion as well, which I can show you now. Or you can have a go just as a bonus question, and then I'll show you how to do it. So, that. It will actually give us the exact same equation. Let's just work through, I'll show you where it comes from. So the displacement, take down as positive, the displacement is 4 meters. If you've not done the equations of motion yet, you may wish to go and check my other video that shows how to do all of this. So the initial speed vertically is 0 meters per second. The final speed, V, acceleration due to gravity is 9.81 meters per second squared. Time we don't need. So simply V squared is equal to U squared plus 2AS. U is 0. So V is equal to the square root of 2AS. So that would be the square root of 2 times 9.81 multiplied by the height of 4. So that will give us the same 8.9 meters per second. The equation's the exact same. When we did the kinetic energy equal to the gravitational energy, the equation looked like this. But it's the same thing. 2AS is 2GH. So when you see a question like this, you can use either method. You can either use the equations of constant acceleration, or you can just do the energy relationship of GPE converting into kinetic energy. Hope you found that useful. Thank you.